Hey everybody, welcome to Deterministic. I'm Brandon Konkle, and this channel is where I explore different ways to embrace more determinism in our programming. I've been a developer for 15 years now, and one of the biggest challenges over that time has just been the sheer amount of chaos that we deal with on a day-to-day basis. It can be relatively easy to get started in programming in a lot of ways. You can use tools to try things out quickly to get immediate feedback as you're changing things. But putting something out there in production and making it reliable, making it something that delivers a lot of business value or does something really worthwhile, that can be a huge challenge. Especially with the kind of dynamic or duck-type languages that are really common right now. There's a lot of hidden complexity that you don't know until it breaks something in production. It seems like the things that you least expect will happen at the worst possible moments. So over time, I've started to look more and more to our tooling, to our type systems, to just different languages and tools that you can use to tame that complexity, to bring that chaos under control. I started out in dynamic languages like Python and JavaScript and TypeScript, but I reached more and more for tools that helped encode intent, helped me as a developer while I'm programming kind of give the compiler or the transpiler information about how I intend my code to be used. And this has been a huge help, not only for working with other people and, people coming in behind you and not having the same context that you do, that the types can certainly help there, but also just help you not shoot yourself in the foot. We're dealing with so much information all the time that it can be hard to go back to something a week later even and try to figure out what was going on there. So the types can really help with that aspect of things, but there's some complexity involved. There's a trade-off, there's a cost. It can be difficult to learn and wrap your head around how these algebraic types often interact together and how you can transform between the different types and use that in different ways. And especially deciphering really intricate type errors that result in the interaction between types that you didn't expect. It can be a challenge. And then another thing is that it can force you to solve edge cases, force you to solve things that might go wrong before they do, before you might have to do the same in a dynamic language, because a dynamic language lets you skip those things. It lets you skip ahead and not handle those things. So I've really found strictness and soundness in a type system to be extremely helpful for not having to keep track of quite so much in my head and letting the compiler do some of that for me. Like I said, I started out in dynamic languages. I spent some time in the functional world, spending a lot of time with the Haskell-influenced solutions like Haskell itself, or OCaml, or in ReasonML in the JavaScript world, or PureScript, things like that. Languages that are very opinionated and have a very particular style of fitting things together in a real tight 0-point kind of way. And so when I came across Rust, I didn't pay attention to it immediately. I didn't see what it was doing right off because it's very different. It's not really the same object-oriented or functional styles that you see everywhere else. It's something new. It's approaching the same problems in a different way that I think is really effective. So not only does it have a really rich, expressive, and sound type system that you can prevent runtime errors with if you use it strictly enough, but it also has this really innovative borrowing or ownership system that keeps track of what function owns what reference, what memory region, what value, and can immediately clean that up when it's not being used anymore. So it's able to sidestep garbage collection entirely and free up memory immediately after it's done being used because it knows when it's done being used. And you can still start going into more reference counted styles like the kind of garbage collection style that you'll see JavaScript or Go or something like that use. But you can choose when you want to use that and how you want to use that, and you can stay away from that entirely if you want to. And then the performance that it delivers is just phenomenal. Because of this new approach, this new paradigm, it's able to deliver performance in some cases that rivals hand-tuned assembly programs. You'll see in one of the articles that I cover today. They talk about an implementation where their rather naive Rust was able to stand toe-to-toe against hand-tuned assembly implementations, and it's really impressive what it can do. But there's definitely a learning curve. And one thing that's really helped me is just staying in tune with what's going on in the community, kind of reading articles, trying to understand what they're talking about and why they're significant, and making my own judgments about things and what I'm interested in and want to look more into. So this new series that I'm starting today, the Rust Review series, will be kind of an extension of that. I'm going to talk about the articles over the last week or two that I found interesting and tell you what I thought about them. And hopefully we can spur some discussion in the comments. I'd love some engagement there with people telling me why I'm wrong, or what am I missing, and what did I completely get wrong about this article over here, or what's something else that I should get excited about. Feel free, let me know in the comments. I'd love to hear from you. So in any case, let's go ahead and kick off this first episode with this week. I am using that terminology kind of tongue-in-cheek because you'll notice that all of my articles come from This Week in Rust, which is a really excellent newsletter that I've been subscribed to for a long time now. It covers not only community articles, but what's going on with the core team and discussions they've had internally, what the big changes to Rust and some of the changes to really popular program or libraries and things in the ecosystem, what's going on. It covers new guides and tutorials and opinion posts and experimentation. It's a really great newsletter. And so though I came to some of these articles before I read This Week in Rust, they're all in there. So This Week in Rust knows what's going on. Definitely check out that newsletter and sign up for it if you haven't. So a lot of my articles you'll see over time probably either come from there or show up in there too. So it's definitely a vital thing to be subscribed to. Check it out. So my first article that I'll talk about today is Linux. This has made major. It's made an impact in just the more mainstream tech news, even beyond just the programming community. But as you can see here, ZDNet is excitedly proclaiming that the Rust and Linux debate is over. The implementation has begun. And this is pretty exciting because this is something that has been debated for quite a while. There's been a lot of question about, will it actually make it in? Will it not? Will they run into something that's going to be a deal breaker? But Linus says he's confident it's making it into Rust 6.1. So the ZDNet article talks about an email that the author received directly from Linus saying that it's going to land in the 6.1 release unless something really unexpected happens. It's going to make its way in. Now, the 6.1 release is a little ways off. It's not immediate. In fact, 6.0 is still in the release candidate stage. It should land pretty quickly, though. It should land in October. So 6.1 shouldn't be too long after that, and that'll be its first introduction of Rust into the Linux toolchain, the Linux kernel toolchain. The recent debate, from what Linus says, is that it's not been around, is it going to happen? It's been more around, how do we make it happen in the right way? Looking at things like integrating Rust into the Clang toolset. Clang is a front end for the C family of languages. Figuring out which compiler versions you need to use. The typical kind of build questions that can be really complex in something like the Linux kernel. There's a lot of different interactions. They talk here that to get it to work, they've needed to make, for example, this Linux SSD driver that they talk about in the article took 70 different extensions that were needed to the Rust language to get it working. But Linus downplays this by saying that we've been using exceptions to standard C for decades, so why not Rust now too? It's a viable argument, and the maintainers had definitely been gaining confidence. You can see as they're talking about that SSD NVMe driver that really kind of showed off the power of what Rust could do in a low-level systems capacity, just like what C and C++ is traditionally used for. So it's exciting to see this happen. Linus is careful to caution that this is just the first steps. It's just getting kind of the foundation for Rust in, but we'll be able to, or they will. I don't contribute to the kernel myself, but those who do will be able to take advantage of it and start using it in the development of the Linux kernel itself. So I think it's a major milestone in the growth of Rust. I think it's going to usher in a surge of new interest in Rust as an alternative to C for this high performance systems computing that you'll see. And I think it's going to lead to better code. It's going to lead to more reliable code with fewer security issues. The kind of memory safety that Rust provides is really exceptional. So check that out. Next up, I'm going to talk about an article from, let me get it pulled up on my screen here. I'll get better at this as time goes on. An article from Nicholas Cameron. He's a principal Rust engineer for Microsoft, and he posted an article over the weekend, or last weekend, about what he sees as the 10 biggest challenges for Rust over the next few years. So it's a great article. Definitely go through and read it in detail because it's got a lot of great information about the state of the ecosystem right now. But the first challenge he talks about is how to motivate contributors to work on the language and ecosystem needs rather than what's most interesting or what they want to work on the most. And I mean, it's a common tension in the open source world for big projects that also have a lot of corporate sponsorship, and it can be hard to get people to work on the things that need to be worked on. And so it holds a lot of projects back. And Nicholas points out that this has gotten worse since Mozilla ended its direct support of Rust and spun up the Rust Foundation, which happened in early 2021. But in considering potential corporate support kind of approaches, he wants to really be sure that Rust keeps this open, collaborative community that's enjoyed thus far. I think Rust definitely stands toe-to-toe with some of the other really great collaborative communities that I've been a part of in programming and open source over the years. And I, too, want to make sure that it continues on that path because I think it's got a lot of potential there. So next, he covers diversity and inclusion. And though, like I said, Rust has a very open and welcoming community, it's actually lagged behind other tech communities when it comes to actual representation. In the article, he cites burnout and hostility towards differing opinions as the root causes, and he really encourages the community to do more to resolve conflict in a healthy way rather than trying to avoid it, which I fully support that perspective. I think we at times can be a little too overzealous in avoiding conflict, and it can hang out and be the elephant in the room that's really holding teams back. So I'm glad that he's pointing that out. Beyond that, other challenges that he calls out are organizational inefficiency, kind of just how slow it can be because it's gotten so big. He talks about a growing and increasingly scattered bazaar of crates. If you follow my blog, you've seen me reference before the cathedral versus the bazaar, the kind of idea of top-down versus a whole market of things. And crate is definitely, the ecosystem of crates is definitely kind of a scattered bazaar at times. It's similar to Node in the NPM world that I'm very familiar with, where there's just a lot of different things out there. There's a lot of fragmentation. So that can be challenging. And then the fragmentation around the async ecosystem itself. There's multiple async runtimes. They're competing, and in some cases, one approach might be better for one use case, whereas another one might be better for a different use case. And that's really powerful. That's a really good thing, but it's also complicated because now you have to pick which async runtime that you want to run with, which is something that you really don't have to think about in most other language ecosystems. So he kind of highlighted the difficulty in making it more appealing, more broadly accessible, without compromising on their goals, without compromising on those core features, the performance, the memory safety, the lack of garbage collection on purpose. He wants to make sure that we don't compromise on that in order to make the language more appealing. Some of this is discipline. Some of this is hardship that is good for us because it makes better software, I think. So, then he shifts to more primarily technical challenges, talking about providing better guidelines and features around using unsafe code, making the standard library more flexible and not quite one size fits all like it is now, and improving the really large and complex compiler that we have now, and kind of smoothing over rough edges in the macros that we can use for deriving things. So it's a great article. Definitely go find it and read the whole thing. You can see the links to all of these articles in my show notes here. But he closes the article with some words of encouragement. Though these are indeed big problems, he really believes there's ways to come together and solve every one of those. And I share his hopefulness. I can't wait to see us overcome these challenges and continue to grow. I think we're on a great trajectory right now. All right, so next up, I'm going to talk about Wasm. WebAssembly is something that is really, it seemed at first to be rather niche. It seemed to be like something that not everybody's going to be interested in. It's more of a front-end thing. It's more of a running in the browser kind of thing. The original kind of pitch for WebAssembly was the idea that you could compile many different programming languages to target execution inside a browser. But Wasmtime and the Bytecode Alliance here, they've taken a different approach. They've looked at how this WebAssembly container, how this approach can help server execution as well. In a context of running on a server rather than executing inside of a browser, it can still be really interesting. There's a lot that you can do, a lot of possibilities that I think that it opens up. And not only that, but it's really extremely low latency. It's the startup time is measured in, where was it? It was, I think it said, I've got to find it now. But anyway, it's got a really just radically 5 microsecond startup time is what it's talking about, which is like, wow, it's less than a millisecond, which is huge, but dramatically less than a millisecond. That's amazing. So if you've worked with big runtimes like Java runtimes, or even getting Node up to speed or something like that, it can have some latency. It can have some startup time. If you're in a serverless context and you've got a cold start, that can be a challenge. So WebAssembly is exciting because it allows for server-side use cases for this WebAssembly format as an alternative to containers or virtual machines. So this would be in like a serverless environment, certainly, but also in an environment that you would typically use with a Docker container or something like that. This can compete with that and provide much lower startup time, essentially. With that 5 microsecond startup time, it can run circles around most of the serverless runtimes that are out there. And it has a plugin system that gives you some protection while you're executing untrusted third-party code. So they highlight some usage. Where was it in the article? Here we go. Yeah, they highlight usage from a variety of different well-known teams, things like Microsoft, Shopify, Fastly. One of the projects that they mention is very interesting to me. It's Fermyon. So Fermyon is it's a project that hosts WebAssembly microservices and they report that they can run tens of thousands of Wasm binaries in a single application instance using their spin framework while still keeping startup times under a millisecond. That's just mind-blowing. So this is it's an emerging space. Let's see, there was one other thing in here. Oh, the spin framework that Fermyon is talking about is really interesting, so definitely check that out. But I think it can really enable some radically fast microservices or serverless approaches, edge deployed approaches, things like that. There's really a variety of innovative use cases that we may not have even seen before. Also, I'm thinking of things like being able to execute code from a user. Untrusted user input should never be executed as code because it's such a huge security risk. But if you can isolate it in the kind of environment that a WebAssembly process runs in, you can guard against a lot of the downfalls in that. And so you can open up more opportunities for dynamically running untrusted user input or user provided code, which is usually a very dangerous thing to do. They talk about the SpiderMonkey team, which is the Mozilla team that works on the JavaScript engines, and they talked about how 400 times faster than the current leading approach. It's just amazing. So credit for this goes to a friend of mine, Alex Kaliris. He brought this to my attention and has helped kind of build my enthusiasm for this. I think it's going to be really cool to see what people do with this over time. Next up, I'm going to cover PostgresML. So those of you who know me know that I'm a huge fan of Postgres. I think I love SQL for one thing. I think SQL is really amazing, amazingly optimized and well-tuned for the kind of relational traversal that it needs to do. And so I still love SQL for a lot of things, and Postgres absolutely is my favorite approach or implementation of SQL. But it can also power a lot of really high performance key value store type approaches. It can be an alternative to something like DynamoDB in some contexts, especially when you're getting into like serverless Aurora on AWS or things like that. There's some exciting things with it. Anyway, I love Postgres, and PostgresML is a project that uses it for machine language. Machine learning. So in order to improve their runtime speed, their memory consumption, their overall reliability, the PostgresML team is talking about rewriting in Rust. They're moving to Rust for their 2.0 release. Now they point out they just released 1.0, so this is still a ways off, but they're announcing their intent. They're beginning the process of moving things over to Rust. And this is notable because Rust is not what you would typically think about first when you think about machine learning. The current leader in that field right now is definitely Python. So they talk about this, they address this, and Python is what their current 1.0 is based on, but they've done a lot of testing and experimenting, and they found that Rust for their needs is about 10 times faster, not only than Python, but also than native SQL or embedded PL/PG/SQL, which is a procedural language that's supported by Postgres. They've found amazing improvements in speed, and they have some benchmarking that they share there. There it was. This was the hand optimized assembly example that I was talking about before. Where did it go? Well, in any case, find the article, read it. You'll find that they used the basic linear algebra subroutines. So the BLAS, it's a spec for low-level routines that can perform linear algebra, and it's implemented in a bunch of different languages kind of as a reference. And one well-known implementation is the hand-tuned assembly implementation, which is just extremely fast. They say that their Rust implementation of BLAS has performed on par with the hand-tuned assembly implementation, which is mind-blowing. Like, for a language with so many conveniences and developer experience features to perform anywhere close to hand-tuned assembly is amazing. But not only that, they're also talking about the ecosystem in machine learning, which is definitely very heavily Python-focused, but in most cases, what they found is that these languages are actually, or these tools are actually implemented in C and C++ or similar, and they have Python bindings, and that's how they're being introduced to the Python ecosystem. Things like XGBoost, TensorFlow, etc. They have Rust bindings too, and in some cases they're having to improve those Rust bindings and fill in some of the quality gaps there, but they're there. It's doable, and it's doable in a very efficient and effective way. So in any case, they're confident that the benefits of switching to Rust and these 10x or more improvements that they're seeing are enough to outweigh the work that it'll need to do to bring kind of the Rust ML ecosystem up to parity with Python. But they make a really good point where some of these things that in more typical scenarios and more typical contexts wouldn't be a big deal become a really big deal when you're handling the massive amounts of information that machine learning deals with. And so a small problem becomes a really big problem in this kind of context. And so Rust may have smaller improvements in some ways, but they add up to really big impacts. And so it's really exciting to see the machine learning world start to move in this direction. I hope they're not the only ones. Because this is definitely a space that I'm interested in and I want to see Rust grow in this area. All right, so I've got 2 more articles to cover. I hope you are enjoying this so far. Like I said, let me know in the comments how things are going. Tell me what I should be doing differently. Next up, we've got an official Rust blog post. This one is about Const Eval. And memory safety or safety rules, borrow checking, things like that inside a Const Eval context. So they share the story of an interesting problem that was revealed by the recent 1.64 beta version. It actually was it saw a final release on Thursday, so it's actually now fully out there. But at the time of the article, it was still a beta, and the ICU4X crate ended up seeing some problems with that beta. Now, this is an internationalization library that targets resource-constrained environments, embedded environments, things like that, with a focus on really small and modular code embedded in a variety of different programming languages and contexts. And on testing the beta version with the crate, the developer encountered errors related to Const Eval, which is when you are defining something that is constant, that is executed at compile time and doesn't change at all through runtime. So this Const Eval code, it allows a subset of Rust expressions to be executed at compile time, and then you can embed the results in the final runtime code. And so this is something that's been a part of Rust for a while now, and this code was working in Rust prior to 1.64. And so now that they added some new diagnostics to Const Evals, it's now reporting an error where there wasn't one before. But they point out in the article that it actually was a problem that just wasn't being called out or highlighted by Rust yet. And in fact, if you tried to use the results of this in different ways, it would actually prevent you from doing that. And so what they're saying is that this change to Const Eval memory safety is something that is proactively moving up when you would hear about a problem. So before this would be allowed silently, and then when you tried to use it in certain ways, it would fail. And now it's just preventing it up front and saying, hey, this is not going to work. So it looked like a new error, but really it's an existing issue that it is more thoroughly detecting now. So the underlying issue is that the compiler can't really tell if you're trying to use a raw pointer in Const Eval. The compiler can't predict what the actual memory address would be at runtime. So it stops it from happening. Now, previous versions of Rust, like I said, it still couldn't predict where this address in memory would be, but it just didn't let you know about it until you tried to use it. So this just follows the problem back to the source and prevents that unsound operation from happening in the first place. So it's a great article. It's really really detailed. It helped me understand more about Const Eval and kind of the greater restrictions around preventing undefined behavior that they have in place for const evaluation, for compile time code execution, and it's very interesting. They link out to Ralph Young's blog series on why pointers are so complicated. And they invite some discussion on the Rust Zulip chat account. But mainly they're hoping that this was just kind of an isolated case, that not a widespread issue. And I think reading through the article was a great way to learn more about Const Eval and how that works. All right, so finally I'm going to finish up with a post from Jimmy Hartzell. Jimmy Hartzell is a full-time Rust programmer working with Savant Power Systems, specializing in embedded Linux systems. He's a fan of strong typing over dynamic or duck typing like you'd see in Python or JavaScript. But he sees a gap when it comes to in-depth examples of how it can actually benefit you. So to solve that, he shared a demonstration of input validation and deserialization that kind of illustrates how the compiler helps you from shooting yourself in the foot, or helps you from forgetting things or not doing things that you might have been going too quickly to realize. So he compares it with Python, and he talks about handling a message that is a JSON message and deserializing that and validating the input so that we can now make use of it in the code. And he points out how this would typically look in a Python context, and you would have a check to see, okay, is this input valid? If not, let's return this error. But he points out that, most of the time this works great if you remember that this could return an error and you remember to check for that error case and handle it. And if you remember this and that, there's a series of things that he calls out that show that if you don't handle it safely, if you don't handle the error, if you just ignore it, the programming language, Python, is totally fine with that. It has no problem with that. Whereas in a soundly typed language like Rust, it forces you to solve those edge cases before you can actually even run the code. So that is, I think, one of the central conundrums in what programming language you choose, because choosing a really dynamic language like Python or JavaScript can help you get up and running dramatically faster in some cases, because you can skip all the edge cases and you can just assume that this is going to be used in the right way or the way that you intend, and you assume it and you don't handle the edge cases and you don't have to worry about it, and you're done a whole lot sooner. But you have this chaotic beast that's going to encounter what you least expect at the worst possible time in production, and sound languages like Rust prevent you from doing that. They block you, they make you handle these edge cases. So further on in the article, he talks about how he would approach this in Rust, and he progressively takes more and more advantage of how the type system will lead you to solving these problems before they even come up. And so it's a great article about kind of how a typical developer on a typical day might easily miss some things that sabotage their efforts to reliably handle user input. And it's this I think is the chief benefit. To me, it doesn't let me use it in a way that could blow up in my face. And that's what I want. I want something that, yes, it might take some more effort for me to learn how to use it effectively, to understand what's going wrong when things go wrong. But once I get the hang of that, I feel more confident in the code that I'm writing with Rust, and I don't have to worry nearly as much about performance and trying to find tricks and hacks here and there to optimize it to the detriment of maintainability. So check this post out. This is another great one. This is the last one that I will cover today. I've definitely enjoyed kind of reviewing these posts in more detail. Like typically I would read through and I would think, yeah, that's great, and then move on. And so preparing for this video, I've sat down and really thought, okay, what is interesting about this? What is useful in these things? And that's helping me understand these things better too. So hopefully, as time goes on, I'll start to invite guests and co-hosts and things like that. I'm hoping to make this a bigger show as time goes on. Maybe I'll even kick off live coding sessions as I'm hacking on side projects in Rust, and kind of invite some discussion as we're approaching different challenges in the code. But let me know what you think. Let me know what you thought of this episode and the perspectives that I had on each article. Feel free to let me know what I missed or what I got wrong. And if you are looking for help with a project, the company that I work with right now, Formidable, is excellent. We have experts that have come through a variety of different disciplines, but especially in the React and front-end JavaScript and TypeScript world, but not limited to React. We work with a variety of different front-end frameworks, and then I focus more on the back end of things. And I definitely would encourage you to reach out to Formidable and find out what we can do on your project. You can also find me at my blog, konkle.us, and I'm on Twitter at bkonkle. You can also find me in Discord and a variety of different servers. I'd love to hear from you. Thanks again, and talk to you later.